Hello everyone, welcome back again. We start again another lesson 4, measure of center. We take today one of measure of center is called mean. So to find the measure of center of data, we summarize all values. We put all your values in front of you, a single number. Now we're going to the mean, the description for the mean. The mean is the sum of all data value divided by the number of these data values. We'll see what this means now. We have in example 1, the dot plot, the number of hours the students spent studying for a history test over a period of 1 week. So I give you here dot plot. This number line give you many values. For 2 we have repeating for 2 one time, 4 two times, and 5 about 4 times, 6 three times, and 7 one time, and 8 also one time. So we have here this your values, this your data, you have it now. So the dot plot closed to be asymmetrical. If you see this line, so we have look like the same, right or left. So we have here 3 1 1, and here 1, here 2, and 1. So it's close to be symmetrical. Not symmetrical, but closed a little bit. So now we're going to the mean is a good measure of center of this data set. So to find the center for this values, I have to find something called the mean. This is our lesson. So why we find this? Because the data distribution is not skewed and there are no extreme data values. For this reason, we find the mean of data show in the plot. We have the numbers. I write 1 2 and 2 4 and 3 and 4 5s and 3 6 1 7 1 8 as this 4 to find the mean. So this our lesson. This is the idea now. We're starting our lesson in this moment. So I repeated or I put my numbers like this 4, and I arranged in the same time. I put the order like the previous lessons. Then I have to find the mean. I told you the mean is, yes, the sum of values over the number of these values. What this mean? The sum meaning I make all of these values plus together. 2 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6, and all these values I make it plus together. And count how many values I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to find the mean, I have to use this rule. This is my formula. The mean is the sum of all values. I make all of this plus. Over the number of these values, I make this counting for this, I make counting for this, and I divide. So this my way. I make it plus all of them plus all these values, and I count all of them. I found 12. From why you found this? You discovered this with me from few seconds. Then I make it mentally, calculate or whatever. I have this result. So now we're going to something else. The next part, how I dealing with this? I give you two data here, data set 1, 60, 60, 84, 84, and so on. The other set 2, you found this, the set 2, 76, 78, all of this. These are your values. I have, or I dealing with two kinds of data. So now I'm going to find the mean for the first one with the same idea, the sum of values divided by the number of these values. So I make all of this plus like this. Then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I divide by 10. My result is my mean, my center, exactly with this value. So the mean here, the close center to my data. Okay. The same way, how to find the mean for this one? So find the mean and spread for each data. I have to make the mean at this form, the sum of values over the number of these values. So I make it all of them plus and count all of them. So I found they are 10 also, but we have different number or the different data here. So I have to make it plus. Then I divide, I have 81. So both of them has the same result, but different values. Does the mean represent typical value in both distribution? Each data set has the same mean, 81, yes. The mean of the second data set could be more accurate measure of center than the mean in the first data. Let's come back again and return back for this last example. I found here my data here, or my number here is 60, 84, 86, 88, 90, but here 76, 78, 80, 80, many 80s here, and 84, 86. You found the number, it looked like close to each other. Here 60 and going to 84 directly, so we have gap here, but here is look like close to each other in the second one. So 76, 78, 80 is the distance, or the range between each two, or the distance between each two is close to each other. But this one is far away, 60 to 84. The gap between them is about 14. So they are different. So for this reason, again, I choose the second one is more accurate for this reason. Study the shape of the data distribution to know for sure the distribution is close to be symmetrical. If the distribution is close to be symmetrical, the mean is a good measure. For the same reason, they are close to each other for the second one, which I explained from few seconds. So if they are close to each other, or they have the symmetrical, close to be symmetrical, so this will be good measure, or the good measure for the center. This good meaning, this the meaning for this part. If they are have something different, if it is skewed, the mean is not the best measure. Mean skewed mean you found something skewed to right or left, so this is not better. So I try to make it as symmetrical will be better. So the goodest choice is all the time the symmetrical, not the skewed one. Okay, as you have to choose the close symmetrical or symmetrical directly. Okay, now we're going to two different data here with dot plots, number line. So this my data here in this example. So the other example, I make it as a dot plot here. So I complete the other example, but with drawing as a dot plot this time. So this the graphing, or this the dot plot for the other example, example 2. So I have to make a conclusion now. Data set 2 mean the second dot plot here has a data distribution that's close to be symmetrical. So this look like symmetrical a little bit. But this we have skewed here. So it's skewed to left or right. We will discover this now. So we have skewed now. So this not good. So the symmetrical is more better. So this is the correct or the accurate one. So the data distribution for the set 1 is asymmetrical. The mean 81 better measure of center of data set 2 than it is for the set of 1, because it's skewed here. Now we're going to something else, another example, page 600. And I give you data 50, 50, 20, 26. You have to order it, will be better. If you don't order it, doesn't matter, but you have to concentrate. Okay, so how to find my mean here? To find my mean, I have to make something. You have to recall your form, your formula, your rule, how I find my mean. To find the mean, again, anyone remember? Yes, the sum of values over the number of these values. So I make all of this together plus. Then I count 1, 2, 3, 4, 5, 6, 7. So I divide by 7. So this is my way. Then I make my operation. This is my result. So I have 38. This is my mean. The plot here like this. This is my plot. So this another example I give you. This is the first example as values data like this. The second example I make it as form of dot plot. So I have to find my mean. To find my mean, I have to see here I have 1, 4, 3, 5, about 5, 6, and 4, 7, and 2, 8. So I make it like this. I found all of them about 15. 1, 2, 3, 4. Count all of them. You found all of them 15. Then you find your mean. So I think this lesson is easy to discover your result. But you have to remember your formula. If you know your formula, you have to replace your formula with your numbers. You have your result. It was easy way. Piece of cake. So we're going to another example. I have two data here, data 1 and data 2. I have to find the mean for each one. So the main idea for this lesson, I find the mean. I have to discover it with my data as a number like this, or from my dot plots. This the two ideas of this lesson. So I have two data. I find my values by adding all these numbers together, counting how many values I have, So I have my result. Like this, I put 5 plus 15 plus 20 and count how many values I found, all of them 9, so I find my mean. This my way. The second one, the same, I make it all of them plus, then I count all of them, then I find my result. So this is the conclusion. He gave it to you here. The mean is good measure of center of both sets you found is look like close to each other in both of them. So they are, both of them are close to be symmetrical. If you find here your values look like close, the difference here about 5, 10 here, about 2 here, sometimes 2 here. So the second one more good, but both of them are not bad. Now we're going to mini example, but here I give you just the final answer. So you know the way. I find the mean by make it plus all of them and count how many values. So I make 41 plus 22 plus 35 plus 46 plus 50 plus 52. Then I divide by 1, 2, 3, 4, 5, 6, divide by 6. So this is my result. The same here, the same here. So I need from you to check your answer, make it with your own way in your notebook or whatever, and then check your answer is right or wrong. I give you the answer for this reason. Now we're going to another example. I give you two dot plots, the same idea. So I give you the first idea to practice with values. Here I give it to you as dot plots. You count, you write 4 plus 4 plus 4 plus 6 plus 6 plus 6 plus 7 plus 7. But try to care when you write any number, write it the same. If you have 3, 6, write 3, 6 plus together. If you make 7, I have the 7 repeated how many times? 1, 2, 3, 4, 5, 6, 7. So 7 plus 7 plus 7, 7 times, and so on. I have another way, but it's not important to make it like this year. Okay? So this easy, make it with the same way. Then I count, I have how many values? 1, 2, 3, 4, 5, 6, and here 7. So 13, 14, 15, 16, 17, 18, 19. So I divided by 19. So I put it all of them plus, then divide. This is your result. The same way here. I make 21 plus 21 plus 21 plus 22 plus 22 plus 22, and so on, and count how many values I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I divided, I have my result. The same here also. Find the mean, round to the nearest decimal. So sometimes I have a decimal, so I have to near. Sometimes I have to tell you I need to round it to how many decimal places. So I have to make it to the hundreds, mean 2 decimal places. Make it plus, count 1, 2, 3, 4, 5, 6. So I divide by 6, I have this result. I round to 80 to become 83. This is my round, and here the same. I make it plus, then I divide by 1, 2, 3, 4, 5, 6, and 7 this time. So I have this result 23. The same way with this number and this number, but you have here to see which one is symmetrical. It's here is very clear is symmetrical here, but here is cute to write. So this the best one will be the first dot plots, will be more accurate, this one. Now this multiple choices, I need to know the definition of mean here. That definition of mean is the sum of values over the number of these values. I want to see if I have many values and all of them has the same mean, 160 here, 160, 100. Which answer will be more good? I told you the symmetrical one will be more good here. Okay. Now the last one, I make it plus, divide by the number 1, 2, 3, 4, 5, 6, 7, 8. Then you round. If you have a round to the nearest 100, if you don't have, will be like this. Okay, I think you understand the lesson. The idea, you use your rule how to find the mean, sum of values over the number of these values, find your answer. If you have round, you have to make it. Sometimes you're dealing with values, sometimes you're dealing with dot plots. You have to make it plus, then divide by their number. You know the answer. Practice with this. We need this lesson, we need it to the next year, inshallah, but with something more. I hope you make your homework to understand the way. If you